Now you've been looking at the cuttings piles beneath the rigs, the platforms, but you've been looking at it in a very detailed way, microorganisms.
That's right, yeah. So drill cuttings piles are often left in situ following the decommissioning process. And obviously these cuttings piles are filled with different types of contaminants, such as hydrocarbons. And the idea of the research was to identify if there was any ability for those contaminants to be degraded over time. And to do that, we look at the microbial communities as they're able to actually utilise these contaminants as an energy source.
Getting hold of that stuff must be pretty difficult.
It is really difficult, yeah. So the way I went about it is actually at a conference in Aberdeen, and there was somebody presenting on their sampling expedition through for drill cutting samples, and I simply got in touch with that person, and after a bit of discussion, they essentially asked if I would like to use the samples. So yeah, it was a nice collaboration between industry and academia to get hold of them.
So how many samples did you get in the end?
There was 4 samples from the drill cuttings, and then about 8 different samples away from the drill cuttings, and then control samples around the side as well. So in total about 50 different samples, which we selectively used based on what the question was.
And you investigated this at a molecular level, is that correct?
Yes, we used molecular microbiological methods to identify which types of bacteria and microorganisms were present in the piles, using a variety of different types of methods.
And what kind of thing did you actually find?
From looking at the different drill cuttings piles, we had 2 different piles, and there was a high variability of different types of microorganism within the piles themselves. But we did actually identify that many of the different types of bacteria were capable of degrading hydrocarbons, which does give some hope for remediation of the piles when they're left in situ.
What kind of timescales are we talking about when it comes to the microorganisms actually colonising, developing to a density, and then actually getting down to work?
It's a really tricky question to answer, and normally to determine sort of degradation rates and colonisation times, we really need to take a time series of samples over months, if not years. With the samples I actually had available to me, I could only really determine what was present at the time, so obviously post-colonisation. And looking at the different microorganisms in there, although we couldn't determine in situ degradation rates, using the information picked up from the survey and from my results, we'd actually use them different organisms in the lab and do some time series experiments and look at degradation rates that way.
And what is the take-home message from this? What was the message you gave to the workshop this morning?
So the main take-home messages were that the microbial variability and geochemical variability of the drill cuttings piles is inherently heterogeneous, very, very variable on orders of magnitude. And in terms of microbial characterisation of the piles, there does seem to be a presence of hydrocarbon degrading organism, which would be able to remediate the piles when they're left in situ, which does give some hope to the decommissioning process, but there's a lot more work to be done, and particularly research and collaboration between academia and industry.